Well, you know that proving theorems is my favorite thing in this course, and so let's take a look at a result and see if we can prove it. So again, we're going to have a bunch of given stuff, and then we're going to ask something to be verified. So we're given this picture, and in this picture we're told that A, B, C, D is a rectangle. So every single property we know that a rectangle has can be employed to do whatever it is we're supposed to do. Now we're also given something else. We're also told that E is the midpoint of AD. So that means that we know that this length, this piece right here is congruent to that piece. So therefore we have these two little segments being congruent. Our mission is to prove that triangle BCE, that triangle is an isosceles triangle. What does it mean to be isosceles? It means that it has to have two sides that are congruent. Which two sides would you guess are going to be congruent? I'm going to guess it's going to be BE and CE. I think these two sides are going to be congruent. Let's think through how we're going to get from the fact that we have a rectangle and this is a midpoint to these two sides being equal. Well, again, let's think through it and then write it out. Now, here's what I noticed. The first thing I know is a rectangle. Look, all the angles are 90 degrees. That means that this angle is 90 degrees, and this angle is 90 degrees. We have two right angles there. And also in a rectangle, I know that this length is the same as that length. So this length right here has got to be equal to that. Well, look at this triangle versus this triangle. I've got side, angle, side congruent to each other. So therefore, we know that these two triangles are actually congruent. Well, if they're congruent, then we know that corresponding parts are congruent, which means that this side of this triangle, the side opposite the right angle, must be congruent to the side opposite the right angle here. These two sides must be congruent, and that's exactly what we want to prove this triangle is isosceles. So now in my head, I see the beauty of the proof, and now it's a matter of writing it all down. And I hope that you'll think about proving results in the same way. First think through it, then write it down. All right, so let's see if we can move forward and prove this thing. This is going to be a long statement, a long and loud statement. Here we go. I'm going to actually put this on its side. We can live with that, I think, because I want to get a lot of this stuff on there. So here we go. So first of all, we know that ABCD is a rectangle and E is a midpoint. That's just the given, so it's no big deal there. Now, angle A and angle D are right angles. A and D are right angles, and that's just part of the definition of what it means to be a rectangle. So that was the first thing we noticed, so that's good. And therefore, they're congruent, because we know by the right angle theorem that all right angles are congruent to each other. So that's great, so we've got that. Now, we're reminded of the fact that this ABCD is a parallelogram, because a rectangle, of course, is a special case of a parallelogram. So all the properties of parallelograms that we have can now be used. In particular, we know that opposite sides are congruent. So AB is congruent to the side DC, and that's because with a parallelogram, we know opposite sides are congruent. So you can see how, by the way, what we did in our heads actually is panning out here perfectly. I'm going to have to start sliding things up a little bit here because I want you to see everything. All right, now I know that AE is congruent to ED. And why is that? Well, because that's the definition of what it means to be a midpoint. So we've got those two. So we've got this side equal that side, that angle equal that angle, and now these two things are congruent as well. And so the triangles are congruent. The triangles are congruent by side angle side. Neat. Well, now we know corresponding parts are going to be congruent. So that means that the BE is congruent to the CE because corresponding parts of congruent triangles are congruent. And then the big finish is triangles isosceles. That's the definition of what it means to be isosceles. Once we have that this length is congruent to that length because corresponding parts of congruent triangles are congruent, that means that this triangle there is isosceles. Congratulations, we just proved a really cool theorem using the properties of parallelograms and rectangles that are at our disposal. I'll see you soon.